So we talked about this with similar figures. And so this k that we're going to talk about is our scale factor. And that's how much bigger or smaller the variable will get, or like the coordinate point. So if you see, we're multiplying by that scale factor. Now, depending on our scale factor, it's either going to get smaller or larger. So if k is greater than 1, so it's bigger than 1, it's going to enlarge. So it will be larger. If k is in between 0 and 1, it'll shrink. And so those are inequalities saying whether or not k is larger or smaller or in between. And so just to remind you guys, when we're talking about shrinking things or make it larger, smaller, these are similar figures, not congruent. So if you guys recall, we talked about things being proportional. We won't have to solve, well, I don't think we have to solve any proportions with it, but we would be able to if we needed to. So kind of show you guys how this works. So I have a shape here that we're going to have to graph. Now on your homework, some of them are already graphed for you, so you might have to like pull the coordinate points off of it. It says to dilate with a scale factor of 1/4. What does that tell me about what the shape's going to do? It's going to get smaller. So 1/4 is in between 0 and 1. So this is going to shrink. So just knowing that going into that is probably helpful, just so that we know what it should look like when we're done. We'll talk about how we do that in a second here. So I'm going to graph it first. This four-sided shape, which my coordinate points sometimes get a little bit off on these. Thank goodness it's not getting bigger, because if it was getting bigger, it'd be way off our graph. It'd be really hard to see. But what we're doing is we're taking all these coordinate points and we're multiplying them by 1/4. So all of these are being multiplied by 1/4. So we're taking 1/4 of all of them. So our E prime, or our new E value, is going to be 1/4 of what this scale, or this coordinate point is. So -8, I'm taking 1/4 of it, it's -2. 1/4 of 4 is 1. So kind of just going through and doing this, they all work out really nicely because they're all divisible by 4. So I'm just multiplying each of them by 4, dividing by 4 is another way to think of it. And now I'll go to graph them. And you're going to notice this is much smaller, and that might kind of throw you off a little bit. You might say, well, it looks like more than 4 of those can fit in there. That's not talking about area, it's talking about the length of the sides. And again, my coordinate points might be a little bit off just because of the way my board's set up, but so this little one isn't 1/4 of the bigger one's area, because more than 4 of these could fit in this little shape. But this side, this is 1/4 of that. This side, that's 1/4. So it's 1/4 of the original length or perimeter. Okay, so you should be able to do that. So shrinking with a scale factor. Now obviously, we can also enlarge with our scale factor. So that's going to be our next one here. So this one says dilate with a scale factor of 2.5. Now since 2.5 is greater than 1, this is going to enlarge, or it's going to get larger. So my first one is going to be very small. Little shape here, and you don't always have to put the letters on, it's just sometimes that's easier for me to visualize what's happening there. But now this time we're multiplying by 2.5. Now that's kind of a bigger pain with some of these, so like for 2.5 times 2 isn't bad, that's just 5. 2.5 times 1 is obviously okay as well. Times 0 is easy, that's 0, but times 3, maybe you have to grab a calculator, but that should be 7.5. So I multiplied them all by 2.5, and then we're going to graph them again. Now 2.5, obviously not the easiest thing to graph, we're just kind of estimating about where it is. Same thing, 7.5. And so just kind of showing you guys, they can also overlap like this. So the fact that the one is kind of on top of the other, that kind of like maybe throws you off visually a little bit, but it is still an enlargement of the original. It got bigger by 2.5. When you guys are ready, we'll flip the page over. We're talking about another notation called vectors. And then if you notice, we only have a couple more examples of some vocabulary words, and then the back side is also like some graphs for our homework. So again, if you prefer these graphs over the ones on your worksheet, you guys can use those, but there's both a worksheet and book work. So we're actually going to make it the odds for all of it, but we'll get to that. Again, when you guys are ready, put that over. You ready to flip it over? All right. So vector notation is just a different notation for translations. So yesterday we learned that with our translations, so like if you guys remember, this is, so if I'm going from A to B, this is what we call the slide, like we slid this across. So this is a translation. So it'd be like a slide. So what this is going to do instead, so yesterday, what we're doing here, this is going to replace when we did x plus or minus a y plus or minus b. It's just going to be a different notation that's a little bit easier to work with. So this is called vector notation. And so instead what we do is we're going to use, I don't know if I know what these are called. They're like not necessarily like less than, greater than symbols. They're not supposed to be used, kind of more of a bracket. So what they do is they take the x and y out of it, and they kind of just shorten it up. So they use these new symbols, but someone who knows math would know that that means we're talking about a vector. And what it does is it takes the x and y out of it because they assume that first coordinate is going to change the x and the second coordinate is going to change the y. So this starts at A. We call that the initial point. The terminal point, terminal means the end. You hear like a terminal illness, it's the end. The horizontal component, they're talking about how much we're moving to the right or left. And that's that A value. The vertical component is how much I'm going to move up or down. And that'll be my V value. So when we're talking about this, I would slide this over, I believe it's 8, to the right. And then I would go down 3. So the way we would write this in this vector notation, we'd write 8 comma negative 3. And if I use the brackets around it like that, then it's considered that vector notation. So someone who would know something about translations would be, oh yeah, that's what we're doing, we're moving it that way. Okay? And there's a lot of different notations, so showing you different ones is kind of important to make sure that you realize if they use that, like again, on something like an ACT or in another class, I know physics uses some vectors, that you would kind of be comfortable with it. So that being said, so we're going to take this triangle and we're going to translate it using this vector notation. But looking at that, I'm hoping it seems reasonable, but all that means is I'm moving 5 to the right and then down 1. So I'm going to graph this, and then I'm going to just move it that way. So I have this long, skinny triangle, and I'm going to move it right 5 and down 1. And I like using the graph more than the coordinate points. To me, it just makes a little more sense. So there's our new triangle. So let me explain what we're doing for today. So our homework, like I said, is going to seem kind of clunky, a little bit longer than typical, but we're going to shorten it up to make it just the odds for both of these. So I have a worksheet for you, and then I also have bookwork. So for this, so for both of these, we're going to do the odds for both of them, for both the worksheet and the bookwork. Now for the bookwork, you're going to need some of these graphs. You will not need all of them. So if you prefer any of these graphs for what you guys are doing, but you're doing odds for both the worksheet and the book. And both of them I need to put in Schoology. I just realized